Every day, AI systems shape how we learn, shop, and make decisions. But for these systems to truly help us, they need to communicate in ways that fit who we are as individuals.
From the Adapt Centre at Trinity College, this is Adapt Radio, presenting groundbreaking innovations, one conversation at a time.
Today, we're bringing you a keynote speech from the Adapt Annual Scientific Conference. It focuses on explainable AI and explores how AI can personalize our experience to build trust and understanding by adapting to users' unique traits. It highlights applications in intelligent tutoring, recommender systems, and health technology, showing how human-centered AI is transforming user experiences. Our guest speaker is an expert in user modelling, personalization, and explainable AI. It's a pleasure to welcome Professor of Computer Science at the University of British Columbia, Cristina Conati.
Today, I want to talk a little bit about the work that we have been doing on this concept of human-centered, personalized, explainable AI. Before going into that, a couple of words about my research, which is at the intersection of artificial intelligence, human-computer interaction, and cognitive science, with the general goal of supporting human-AI collaboration. And on my end, I aim to do that with a specific approach of building AI systems that can, during the interaction, understand the needs, states, traits of their users, personalize the interaction accordingly, and very importantly, do that by abiding to the good principles of human-computer interactions, including preserving transparency, user control, and trust. In order to have this AI-driven personalization during interaction, what needs to be done is to establish what we call technically the AI-driven personalization loop, where one goal, one task of the AI is that of taking information from what the user is doing with the interface, with the interactive system, and infer relevant user properties from information that is usually limited and ambiguous, possibly. Researchers have looked at having AI being able to infer user goals during the interaction, user performance, user knowledge, cognitive abilities, but even things a bit more esoteric, including user emotions, personalities, preferences. Of course, these properties are constructs that can be difficult to understand even by a human during human-to-human interaction. For instance, emotions. Some of us are better at understanding emotions of others than others are. So as you can imagine, there is a lot of ambiguity to build these properties. So one avenue that researchers have looked at is trying to increase the bandwidth of the information that comes from the user interaction with the system by using a variety of different input sources, not just vanilla interface actions that could come from mouse or interaction with a keyboard or a touchpad, but also other things such as, for instance, having situations in which users are wearing physiological signals that can provide the AI with information about their emotional reactions, looking at facial expressions, looking at eye tracking, and again, these are just some of the examples of the multimodal signals that people have explored to be able to build user models that are reliable. Once the AI has managed to infer whatever property is relevant for the current interaction, then what needs to be done is decide what to do with this information in order to personalize the interaction to the user. That's the second place where the AI comes into place. So how to make informed decisions based on the information on the user, in the user model on how to personalize the interaction. And again, how to personalize, there are many different ways in which it can be done. People have looked at enabling the AI system to provide help, for the user to accomplish the task that they're trying to accomplish, tailor, personalize how the information is presented to the user, adapt the interface itself. So for instance, so that unnecessary actions can be hidden and relevant ones emphasized, provide recommendations. And again, these are just some examples of possible personalization actions that the AI can take. And this is the part where the human-computer interaction aspect of this research comes into place. Because whatever we decide to do, whatever kind of personalization we decide to deliver, that needs to be done in a way that it's non-intrusive and it's acceptable to users. And there's where we need to take into account all the principles that researchers in human-computer interaction have been investigating for several decades at this point. So this field of AI-driven personalization has been around for several decades. I want to say that because in a lot of papers that we read now that are using, for instance, Gen AI, they tend to forget. They're like, oh, look, now with AI, we can personalize because the LLM can say something that is like related to the personality of the user. And they completely disregard the fact that this work has been going on for, again, several decades, with applications in recommender systems is the most obvious example of this research, but there has been a lot of work in intelligent tutoring systems, smart homes, personalized health, assistive technologies, entertainment, and so on and so forth. So, of course, nowadays, there is an explosion of interest for these kinds of themes because of the new AI renaissance, and with that, a really strong interest and focus on this idea of human user-centered AI, which perhaps back at the beginning of the research in AI-driven personalization was a little bit in the background, but now it's becoming more and more important that these themes are, and the humans and users are at the center of this research. So I just want to say a few things, some terminology, okay? If you read literature on AI-driven personalization, you might find other ways in which is referred to. So for instance, adaptation or user adaptive interaction. So these are all synonyms. Then there is also this idea of user-driven personalization, which is also known as customization, where instead of having the AI personalizing the interaction, the interface or the interactive system provides affordances for the user to personalize as they like, okay? So this is a customization, and these are complementary approaches. They are not fighting each other. They are things that can both be useful in different times and different circumstances. So essentially, leveraging these two can really give the spectrum, shown there, of different type of mixed initiative interactions, where mixed initiative is a term that was actually first proposed by Eric Horvitz, one of the top researchers in this field, in 1999. And the idea is really that you have at one end an extreme in which the AI is driving the personalization without even taking the user into account. At the other extreme, the user is customizing on their own. But then, in between, there are a variety of different ways in which the AI and the user can collaborate to find the best way to personalize the interaction. But back to the main focus of this talk is, as I said, super important that when we have AI-driven personalization, we'll still maintain user control, transparency of the system, and enable user trust. How do we do that? And this is a question that researchers in AI have been grappling with for now quite a while, since, again, this new AI renaissance, where the idea is, how can we make AI more understandable to its users? And that's where the field of explainable AI started, where the idea is to increase the interpretability and understandability of AI-driven systems by enabling the systems to explain to their users their inner workings and how they are making, how the AI system is generating a decision, is generating an action or an output. Usually there are, different constituencies or stakeholders that could receive these explanations, and usually the two rough way to divide them is whether explanations are for model developers, so the AI experts who built the model, and because some of these models are black boxes, sometimes the model developers themselves need techniques to understand what's happening with the model. And I'm referring to deep learning, of course. But the other group is end users, like the actual users of the AI agent, of the AI technology. And these could be users who are not technical at all. And these are the users that I will refer to in the rest of the talk, okay? It doesn't mean that explainability and interpretability for model developers is not important, but a different set of things that one needs to take into account, so not for today's talk. So then explainable AI for end users. Do we need it? Do we want it? So there are quite interesting results showing that, yes, enabling an AI system to explain its behavior to their end users can be useful to increase trust, increase understanding of the users, increase acceptance. However, there are also results showing that not all users want or need explanations. There are times when, in specific circumstances, in which some users might say, no, I don't need an explanation. I'm okay with adopting or dismissing the AI output. So essentially, there is mounting evidence then that one-size-fits-all explanations don't work. We need explanations sometimes, but when, how, it's something that we're still investigating. So moving forward, what is very important is really trying to understand what are the factors that can really bring out the effectiveness and usefulness of XAI for end users. And these factors span context. So what is the application domain that the AI is being used for? What is the criticality, the level of criticality of the tasks that the AI is supporting? One thing is the AI is recommending movies to watch. One thing is if the AI is recommending what to do about a very serious surgery. Different levels of criticality, right? Whether or not you want explanations from the AI might depend on this. Level of AI autonomy that you want the AI to have. Should the AI just make the decisions and just give me the rationale? Should I be involved in the decision? So level of autonomy is another factor that needs to be taken into account. And then, of course, there are also dimensions and properties of explanations. Explanations are a very complex constructs. We have been talking about explanations in AI and computer science, again, in the last few years. But explanations are something that philosophers have been looking at for a long time. Philosophers, psychologists, right? So not a new concept at all. And there are many different dimensions. Like, what is it that we're explaining? There are many different types of explanations. For instance, why you're doing something. How did you come up with that particular action? Why not to do something else? Counterfactuals, alterfactuals. I won't list all the different types of explanations, but there are many. How, once you choose what to explain, how do you explain it? Do you provide some text? Do you provide images? Do you provide a video? Do you narrate? So the medium that is used to deliver the explanation can also have an impact on the effectiveness of the explanation themselves. So level of detail. These are all factors that need to be studied. I haven't even, people started looking at them, but just in a very preliminary manner. And these are important dimensions. And across that, I claim that user differences can play a role and need to be investigated, okay? These cut across all these other dimensions. And that's where this idea of personalized explainable AI come into place, where essentially the vision that with my group we're working towards is this idea that we want to create intelligent systems that can understand to whom, when, and how to provide explanations of their behaviors. And I just want to reiterate here, when I talk about explanations, I'm not talking about domain explanations. I'm talking about the AI explaining itself, explaining to the user why the AI generated a specific output or a specific action. And also, we want to always have good user interface affordances that enable the user to interact with the explanations in a way that preserve their control and their acceptance. So essentially, going back to that personalization loop that we were looking at earlier, the idea is that explanations should be another form of personalization. And that could be, deciding what to explain, how to explain it, and so on and so forth. What we don't know much about is which user traits should be taken into account or should be considered to personalize the explanations. That's something that is still very much an open research question, and that's why there are all those question marks there. Researchers have started trying to kind of address some of those question marks. In our group, we started looking at the impact of long-term user traits on personalizing AI explanations, where long-term traits means traits that are not changing over the course of the interaction with an interface or an AI, okay? So we're talking about things such as personality traits, cognitive skills. These are things that might change in the long term, but they tend to be quite stable in a short period of time. And this could be in contrast with short-term states such as emotional reactions that could, that change rapidly as you are interacting with an AI or a human. And so we already have some exciting results for impact of these long-term traits on AI explanations for the hints generated by intelligent tutoring systems, so AI agents that are designed to help people learn in a pedagogical setting, and also explanations for music recommendations generated by an AI system. So I'm going to be talking a little bit about some of these results in the rest of the talk. Just want to give you a sense of the overall methodology that we have been using for this work. So essentially what you want to have a system that delivers AI-driven personalization. You want to have a version of that system that just deliver the personalization without explanations, and a system that is able to explain itself and why the certain personalizations have been offered. And we want to compare the performance of these two systems, going back to what we were saying this morning about the importance of evaluating explanations, right? We want to compare the version of the AI-driven system with and without explanations in terms of performance. Does having explanations improve user performance in whichever task we're looking at? And also in terms of user perception of the AI behavior itself. Do explanations improve users' acceptance and perception of the AI performance, okay? And we do that by always, when we set up the experiments, beforehand, we give users existing tests for user characteristics that could be relevant and might have an impact on the effectiveness of AI explanations, okay? So this is the general idea. And after that, the data analysis is done so that we can uncover effects of having versus not having explanations of the AI behavior, and whether these effects are mediated by personal characteristics, okay? So I'll give you examples. So if this sounds a little bit esoteric, we'll see examples in a little bit. So I want to start by talking a little bit about the results that we got with creating a framework that enabled an intelligent tutoring system to explain its actions to its users, which would be students. So the system that we were working with is this, it's called ACSP, Adaptive Constraint Satisfaction Problem Tutor. Doesn't matter, the name is a long acronym, but essentially this is a system that is designed to help students who are working with an interactive simulation that enables them to explore the workings of some specific software algorithms. The system tracks how the students are using the interface, this interactive simulation, predicts whether a student is learning or not from the interaction, and when it decides that the student is performing actions that are not conducive to learning, it generates some hints that try to steer the student from more profitable or useful behaviors. So again, without going into the details of the system, some of the hints that the system generates in real time during the interaction would say something like telling the student that the student has been ignoring some useful action that it's available in the system. In this case, it says, you rarely use direct art click to tell the algorithm what to do. Again, it doesn't matter the content, but it's just trying to flag and bring the user to use an interface action that it would be good, but they have been ignoring. Why don't you give it a try? Another one, it's, for instance, flagging that the student has been using an interface action too much, relying too much on it. So in this case, it says, you're often using auto-art consistency. Please consider some other option. Okay? These are the style of hints that this AI-driven tutor generates. We evaluated the system quite long ago in terms of, are these hints generated from this underlying AI useful? Are they actually helping students learn? And in a study, we showed that yes, if students have these hints versus just working with the system without any AI support, they learn better. However, of course, they learned better, but we didn't have a ceiling effect. They didn't get 100% learning. So the question that we decided to ask was, could these hints be made even more effective if the system can explain why the hints were generated? And does this effectiveness of explanations, if any, could that depend on specific student characteristics? So essentially what we're trying to ask here, so to just give you a sense, so the adaptive loop for this tutoring system, the vanilla version, the system takes user actions. In the learner model, the system tries to infer in real time whether the student is learning or not. And if the student is not learning, what are the behaviors that are causing this suboptimal learning? And then the system generates the hints that I showed you to try to improve the student's learning from the interaction. So now what we want to do is to add an additional level. We want to add explanations for those hints, and we want to understand what are the student properties that could be useful potentially to make these explanations compelling and effective. So what I want to show you here is a graph that shows the underlying AI that this ACSP tutor uses to decide if a student is needing hints or not. So essentially what it does, there is some behavior discovery that is data-driven, offline clustering, and association rule mining. So there is some data mining that is used beforehand to learn from data what are behaviors that the system can use to predict if a student is learning or not. Then there is some user classification. There's a classifier that is built from the offline clustering that the system can use in real time to detect if the student is learning or not. And then there is a variety of techniques that are used to decide which hints to give to the student, okay? So this is just to show you that the underlying AI is quite complex. It's not a deep learning architecture, so it's not a black box. It's possible to verbalize what's happening, okay? Because these are techniques that are pre-deep learning. They are much more interpretable. Still, the problem is a lot of stuff to explain to a user who is a student, who is using the system to learn something. And now we need to be able to relate this information to explain the system behavior. This brings to this idea that, designing explanations is hard because the underlying AI can be complex. And the users we're talking to are not AI experts necessarily. Most of the times they're not, right? So people have been looking at some criteria and frameworks to describe what would be good properties for explanations. I'm just focusing for this talk on this work by Kulexa and colleagues from CHI 2015, where, among other things, they said explanations should be iterative. Even if there is a complex set of things that needs to be told to explain the system behavior, the explanation should be designed so that a user can choose at what level of detail to go deeper. They should be truthful, also known as faithful. That's what I was discussing this morning. So the explanations should not be simplified to a point which they're not even reflecting what the underlying system behavior is. They should really try to convey the decision process that the AI is using. And should also be not overwhelming, meaning they should not interfere with the primary task that the user is trying to achieve. In this case, when he was interacting with a tutoring system, the user was just trying to learn. Now, what we did, so when this tutoring system generates one of its hints, like, hey, you're forgetting to use, you're overusing this action, at the bottom, the student can click on, why am I delivered this hint? They can do it or not. It's up to them, okay? But if they click on that, why am I delivered this hint, they receive a first screen where there is 3 different tabs. The first is why am I delivered this hint, and there is an explanation that talks about one part of that big graph. But essentially, this screen gives them access to 5 different pages of explanations. That's a lot of pages still, where the 3 pages at the top talk about why. They try to convey why a specific hint has been generated, and this is really derived from the underlying user model and AI. And from there, the users can also dig a little deeper and ask how some specific aspects of the behavior have been computed. Again, I won't be able to go into the details, but I want to show you that here we're focusing on why and how explanations, which is just 2 types of explanations over the several ones that exist. We do this because we did a pilot study beforehand where we were asking students, if you could ask for explanations for the AI behavior, what would you want to know, okay? And why and how were the highest ranked. That's why we're doing that. But essentially, the student can navigate through this interface as they like, right? They can access the tabs and go down into the hierarchy. We spent a long time pilot testing the delivery format to make sure that it was understandable. And understandable is a crucial property of explanations. In the end, we actually ran a study that kind of follows the methodology that I explained at the beginning, where we have the 2 versions of the system, one that shows just the hints, and a version where the student can ask, why do you give me this hint? okay? So it's a formal user study with control group and experimental group. And also we checked for possible impact of various user traits. So in particular, we had 2 groups working with the ACSP with and without explanations, 24 students in one group, 16 in the other. Students took a pretest on the knowledge that they were supposed to learn during the interaction. And we also gave them tests for possibly relevant user characteristics, which include 5-factor personality trait. Is a very famous model for personality that includes 5 different personality types. Need for cognition. This is a very well-known construct in decision theory and essentially measures one desire to always go deeper and think more about the things that they're doing. Reading proficiency and perceptual speed, visual working memory. These are traits that relate how proficient you are at reading or processing visual information. And we put them there because there is visual information and textual information that they need to read. So that could impact how effective the explanations are depending on the levels of these abilities. After the study, students take a post-test on the knowledge they're supposed to acquire when working with the system to see if they're learning. And also we gave them a questionnaire on perception of hints, because that's what we want to know. Are they feeling better about the hints that they receive from the tutor, and also on the explanations. So essentially the analysis of the study data aimed at looking at the effect of explanations on perception of the hints and learning. So I'm just going to give you an overview of some of the results. Again, the paper has many more, but so explanations and hint perception, there was a significant effect of explanations on intention to use the system again with the hints, helpfulness of the hints, and trustworthiness of the hints, where the system with explanations generated higher ratings than the system without explanations. So in that sense, the explanations are achieving some good outcomes. We also noticed, so during the studies, I use a lot of eye tracking. We use a lot of eye tracking in our research. So in this case, the students were also having their gaze tracked with an eye tracker. And that showed that users with higher need for cognition looked at explanations much more than students with lower need for cognition. It's kind of intuitive, because high need for cognition, they like to know more. But if you look at, we're looking at these individual differences to see if that would suggest ways to personalize the explanations. And here, one possible personalization that is suggested by these results is that we could encourage, since students with low need for cognition tend to not look at explanations, but explanations seem to be useful, given the previous slide, maybe we should find ways to encourage these low need for cognition users to look at explanations. Another thing that we found, did explanations help increase student learning with the system? We found an interaction effect between having and not having explanations and having high versus low need for conscientiousness on learning gains. Conscientiousness is one of the 5-factor model personality traits and describes one tendency to follow suggestions, follow the guidelines, comply with rules and the goals and tasks given. So we found that users with lower levels of conscientiousness learn more when they have the system with explanations than without. And that's the opposite for users with higher levels of conscientiousness. We actually don't really know why. It's hard to explain this result. So possibly explanations provide motivation for lower conscientiousness users, but we don't know. What we know is that this is another result that shows that individual differences somehow have an interaction with having or not having explanations. And here, and suggest possible ways to personalize. Here, a possible personalization would be because students with low conscientiousness benefit from explanations, we should encourage them to look at explanations if they're not doing it. So we have these two things that came out of our results, these two suggestions on how to personalize the explanations. So essentially, the results that I showed you can be summarized by saying that the way to personalize would be to encourage interaction with explanations for students to have or score low on conscientiousness and on need for recognition. Because they're not looking at the explanations, and when, if they have low conscientiousness, looking at explanations is good for them. So we designed a variation of our explanation-based tutor with, instead of the original version that I described so far, would provide explanations only if the student asks for them. Student needs to click on that button at the bottom. But we decided to try and see what happens if, for students with low need for recognition and low conscientiousness, the system proactively offers the explanation without waiting for the student to ask for it. So, as soon as the student receives a hint, if we know that the student has low conscientiousness and low need for recognition, the system brings up the explanation right away, the first page. Then they can ignore it, but at least it shows that the explanation is there. So we ran another user study to compare these two. So essentially, we collected users with low conscientiousness and low need for recognition, which took a long time to get enough participants with those characteristics, but we did. And another thing that this version has, the one that is more proactive, it also tracks for how long a student is looking at the explanations, and if it's kind of, spending not enough time, the system provides a little prompt, why don't you stay with the explanation a little longer? But essentially, again, I won't go into the details of the data analysis, but they are in the papers that are mentioned up at the top. But essentially what we found is that when we have students with those types of user characteristics, if the explanations are provided more proactively, we get a significant, as in statistically significant increase in attention to explanations, and even more importantly, significant positive effect on learning. Okay, so these users, when they get the more proactive offering of explanations, tend to learn more overall from the interaction with this intelligent tutoring system. So that's a very, interesting, a rather strong result. So we're pretty excited about it. But essentially, what we find is that going back to our personalization loop, it would be good for this particular intelligent tutoring system to personalize the hint explanations to conscientiousness and need for recognition in the way that I described. We have similar results with a different intelligent tutoring system. I'm just gonna give you a very brief overview of this, just to show you that it's a different environment. In this case, we have a pedagogical agent that is helping students solve problems. This is in the domain of logic, but the system is suggesting whether the student should try to solve the problem on their own, look at an example, or rely on the help from the agent. This is more like along the lines of teaching students how to study. So it has these three kinds of suggestions. We were providing justifications of these suggestions based on a student learning goal attitude, where learning goal attitude is, are you doing something in a pedagogical setting because you want to learn, so learning oriented, or because you want to get done with the task as soon as possible? It's called efficiency oriented. We didn't come up with this. It's something that comes from educational psychology. So for instance, if a student is learning oriented, the suggestion of the system would be accompanied by saying, if you do this, this will reinforce your knowledge of the domain. If you try to solve the problem by yourself, that will reinforce the knowledge of the domain. If the student is efficiency-oriented, the justification would be this will help you solve the problem more efficiently. So even these just simple qualifications actually increased learning gains. So providing the explanations tailored to a student learning attitude increased learning with the uptake of the suggestions and learning with the system. And I just want to briefly mention that we also have results in a very different domain that has nothing to do with education, but music recommender systems, where we have a music recommender system that is built on Spotify, provides suggestions on what music the user should listen, given on the existing information on what the user has liked before. And in this case, it's based on the user can specify music attributes that they appreciate, those 5 things, bars or 6 bars. And then as the system generates suggestions, it explains its suggestions based on how those suggestions score with respect to the user preferred values for those attributes. And the user can explore. There is a variety of other visual things that the system does to justify the recommendation. And even here we saw that, so we have evidence that personality traits influence how these graphical explanations work, if they work for users. Those results gave us insights on how to personalize. And then in the last paper at the bottom, we showed that these personalizations based on user characteristics improve the effectiveness of the explanations. So we're talking about very different domains. So we have looked at, if you go back to that slide where context is important, right? We looked at education, where criticality, we could say it's medium. We looked at explanations for recommendations of music, where the criticality of the task is fairly low. And we're now looking, I'm just going to quickly talk about this new project that we're working on, where we are looking at health, where obviously criticality is high. And where we were doing in this particular work is play with the medium that it's used to deliver an explanation, so text graphics. In this case, it was a system that was providing recommendations to users who suffer from chronic musculoskeletal pain, which is a condition that is affecting a large portion of the population and is really debilitating because people are in constant pain. So there are ways to, in addition to try to diminish the level of pain, but also mentally help users to deal with the pain. So this app that we describe in this paper is trying to provide recommendations to users on a daily basis on how to deal with the side effects of being in constant pain. So for instance, it could suggest something like learn how to recognize unpleasant feelings and cope with it. And what we did here in this work, we played with different ways to explain why the system is providing a certain recommendation and how. So we played and looked at different explanation formats, and if the effectiveness of these explanations could be mediated by need for cognition. Need for cognition is the trait that we found to be relevant in other work. So again, just to give you a quick glimpse, in this particular paper, we tried to provide the explanations in a textual format, in a visual format, or in a hybrid format, where we combine text and graphics. And in this particular case, we found that hybrid explanations that combine visual and text worked the best. We did not find an impact of need for cognition. So this particular trait is not relevant to personalize. But of course, we just tried this one this one trait. So it would be important to look at other different user characteristics might impact, especially things that relate to user reading proficiency or abilities to process visual information. I want to say that, we're working a little bit, we're really going into this deeper into the idea of AI explanation, explainable AI for health. It is obviously a super important domain because of the criticality of the task, and so much it's, what is at stakes when you use AI for health-related decisions. And, but the whole point of this particular project is that we want to engage users and stakeholders, in this case, patients, doctors, relatives, early on, because again, it's not necessarily clear how much people need explanations or what kind of explanations they want. So in the medical domain is something that we're really hoping to go a little deeper in. So what I hope I've done with this talk is to provide some initial evidence for the need of personalized AI explanations. I've provided evidence showing that this seems to be useful if we take into account long-term user traits. But what's next? I keep saying that, we're just scratching the surface, because we would need to look into the impact of long-term user traits in different applications and different stakeholders. Would be super important to look more at the interplay between user characteristics and explanation properties, because I showed a little bit of work that we've done by playing with text, graphics, and combinations of the two. But that again is just one piece of work, but there's much more work that is needed to understand what type of explanation would be most useful for different users, the level of detail, delivery method. Super important also looking at short-term user states, what the user is feeling or thinking, in a transient way during the interaction. So for instance, one would imagine that confusion could be a state useful to decide whether the AI should present an explanation or not, an explanation of its behavior. If the user is confused about the user suggestion, perhaps that's when an explanation is called for. However, if the user is already in cognitive overload, another short-term state, well, maybe that's not the time to provide an explanation because the user is already overwhelmed about other things, right? So short-term states are super important to look at, difficult because they're hard to track, but exciting from a research standpoint. And then last but not least, super important, understanding the interplay between explanations and under or over reliance with AI. So this concept of do people under rely or over rely on AI has been looked at quite a lot, again, due to the fact that now AI is becoming part of our daily lives, and explanations can really play a big role in either one of these more negative outcomes of interaction with AI and try to find the best balance where you do like the just kind of reliance on AI. Okay, I'm done. So I want to thank the people who have done the actual work here. And I also want to thank you for your kind attention.
Thank you very much, Cristina. So I'd like to open the floor to questions.
Hi, I'm Dave Lewis from Trinity College. Thanks very much for your presentation. That was really interesting. And I like at the end where you were touching on some of the, potential drawbacks or, things that we should be concerned about. One thing that springs to mind, the application you had was in education where the explanation obviously had a performance benefit in terms of perhaps metacognition that it was improving. But, some of these other areas such as sort of medicine or other places where you're subject to algorithmic decisions are now, well, we're not quite sure whether there's going to be a benefit yet, but things like the AI Act and previously GDPR has some provisions that, companies should provide some explanation if it's requested. Okay. So do you think there's a danger that if you were automating the provision of that explanation, but you're doing it primarily in a legislative environment, it might, and the personalization might be used to adjust the explanation to optimize for a particular outcome. So if you have someone who you say is particularly has very low agreeability or highly neurotic, you give them an explanation that minimizes the chance of them complaining or suing you.
Totally. Yes, absolutely. No, that's a great question. And as I said, I put that point last, but not because it's not important, it's actually crucial, right? So all these studies on explanation should really start looking at what happens when the AI is right, and then there is an explanation, right? What happens when the AI is wrong and provides an explanation, right? When it's, it's essentially 2 by 2 and all the different outcomes. So, and how user differences play a role there. This is like almost uncharted territory, but super important, because then there is this problem of, persuasion. The explainability could be a means towards persuasion that is not necessarily the best kind of persuasion. So how to get there, it's a big question. And I just hope more and more people start looking at that, because it's a lot of work too. Because for each of these studies, they are already very time-consuming. You would need to also inject this accuracy of the AI, right, which is super important. I also want to kind of latch on what you were saying about the first system. The performance measures were very clear. It's learning. Already, when we're looking at a recommender system where, and again, low task criticality, but still, right, the system generates suggestions, and the user would say, yes, I like the suggestions or not, but you don't have a very formal quantitative measure of performance, because whether the user puts them on the say playlist, and that's a success at the birthday party, it's something that you don't know up front, right? So how to evaluate contexts where you don't have an immediate measure of performance available, it's also challenging, for sure. Yeah, absolutely. Thanks.
Hi, I'm Eamon Sullivan, Maynooth University. So, because I work in looking at the gig economy and the algorithms that sort of give or allocate work to people.
Sorry, you said
the gig economy. So like Uber and Free Now, all these kind of, so that's my research looks at that stuff. But what I'm wondering is, because we have a problem trying to get explanations for decisions that are algorithmic decision making. And sometimes it's not in the interest of the apps to share that information. And I'm wondering, what can be done, or, if we can compel the companies to give these kind of sort of readable explanations, how can we make sure that the explanations that they're giving us are correct, or, that sort of stuff? I don't know if you can
that's a great question. So, and again, this goes back to this issue of faithfulness of the explanations, right? So first of all, if there is a company involved, how can you make sure that they're dead? I don't know. More of is depending on the type of AI, and I didn't really touch on that, right? All the AI that I talked about is more interpretable. So it is possible to give truthful explanations. Then whether the company wants to do it or not, it's a different story, right? But it is possible because the techniques are more interpretable. None of the systems that I talked about use these black boxes like deep learning, right? Once you get deep learning into the picture, it's not only, how you generate the explanations that there, but we don't even know if the explanations are truthful mathematically, okay? So there is work in trying to, so in that case, given that a lot of these products that possibly, these companies are working with are using less interpretable models, that's a big question, right? Are the explanations correct? Not necessarily are to define. So if the underlying AI is interpretable, then it's just a matter of ensuring that the company does what they need to do to generate the correct explanations. But if the underlying AI is not interpretable, then it's a bigger problem, right? So.
Thanks for the talk. My name is José María Alonso. I came from Spain. I'm visiting here. the university, and I really appreciate your talk because it's a topic that I'm working a lot. And I want to ask your opinion about the issue that in Explainable AI there are more and more people working in recent years, but there are not so many people looking to the human-computer interaction, to this type of user studies, because I understand it's difficult to make studies with humans. So what's your opinion about the sample size, the effect, the reproducibility of these experiments? Because I'm convinced that we need more and more experiments like this to prove that this is useful. But there are many people from the machine learning perspective that they try to look for metrics that are automatic, and they never ask humans if they appreciate the explanation or not.
Absolutely. So thanks for the question, because that's a big problem that is sort of like slowing down the advancement in this field. So there is some, I would say not everybody, right? But some groups or research subfields in AI that you're right, they're still not looking at users at all. Now there is also the other trend. So if you go to some of the HCI conferences, now they are also attacking the problem in a way that is not necessarily the best way, because they set up studies and they're not necessarily using the right AI, or they're not using the AI in the right way. So the studies that sometimes come out of the HCI venues have the confound that they're making claims based on the fact that they're not using the right AI. Okay? So how do we bring these two streams together and join forces? It's a big question. And of course, what you mentioned, the fact that running these user studies is hard. And that's why if you are in a field where it's enough to just show some, theoretical results that is based on running algorithms on some metrics, why would you go and create yourself additional work and additional trouble by running user studies? Unfortunately, that's the problem, right? So I think it's really a matter of getting these two camps to talk more. And it's happening a little bit, because now in some of the AI conferences, you see tracks or workshops that bring the user into the picture. And in the HCI conferences, you see tracks and workshops that try to bring the AI people. But I don't have a magic solution, but it's a problem. And I think more and more people are becoming aware of that. And what is important to realize is that although there are some AI people who are ignoring the users, there are many, many more who are not anymore. So I think there is more work that is becoming principled and user-centered. Sample size, reproducibility, that can be a problem because it's just so hard, right? In one of my studies, I had, 24 people and 16. You're like, well, are you lazy? You could have gotten more. It took months to get the right number, because there were so many constraints on the features that these students needed to have just to not avoid confounds in the study, right? So sometimes you just have to accept that some of the results are not built in the best experimental conditions because, there's something got to give, right? It's better to have studies that are suboptimal, but as long as you qualify and you understand the limitations, right? So if you can only have 20 users, just do it with 20 users and try to understand what you can get from that to move on to a bigger study, right? So I think it's important to, in Italian, we say the optimum is the enemy of the good. So sometimes you need to do that.
And that was Professor Cristina Conati from the University of British Columbia. She was speaking at the ADAPT Annual Scientific Conference. If you'd like to find out more about what we spoke about today, you can find lots of information in the show notes and at adaptcentre.ie. That's it from our podcast this time round. Until next time, from myself, Claire O'Connell, Slán, and thanks for listening.
The Adapt Radio podcast is brought to you by the Adapt Centre at Trinity College, Dublin. Find out more about their extensive research work at adaptcentre.ie. Join us next time to hear about more groundbreaking innovations. To get new episodes automatically, just click the follow button on your player right now. The Adapt Radio podcast is produced by dustpod.io, with episodes monthly on Apple, Spotify, and wherever you get your podcasts.